Imagine this. Traveller, a silent object gliding past the edge of Mars, growing brighter, in a way no comet ever should. You weren't pulled here by accident. Something in the universe wanted you to hear this story. 3I Atlas, now among the largest interstellar objects ever detected, has begun behaving like a question written across the sky. What if its impossible tail pointing straight toward the sun is more than a coincidence? What are the odds of such a visitor appearing in our age of instruments and wonder? As it races toward perihelion, the mystery deepens. Stay with me before you fall asleep. Traveller, tonight the universe whispers in the language of numbers. They drift across observatory screens like small quiet signals from a distant mind. At first, 3I Atlas appeared to be nothing more than a faint visitor, a smudge against the dark barely worth a second glance. But as the days unfolded, astronomers noticed that something subtle, almost shy, had shifted. The brightness curve began to break its own predictions. Magnitude values, which normally follow patient and predictable rhythms, started to fall with an urgency that felt out of place. In the strange logic of astronomy, lower magnitudes mean more light, and this object was brightening with a speed that resembled intention more than accident. Such changes aren't supposed to happen this way. A comet warms, sighs out gas and dust, and reveals its glow through slow, steady breaths. But 3I Atlas brightened like a heartbeat sharp, sudden accelerating with each observation. Earth-based telescopes confirmed what the models refused to accept. This interstellar wanderer was not merely heating, it was awakening. And you, listener, did not arrive at this story by coincidence. Something in its unfolding called to you a pull of curiosity, of unease, or simply the quiet sense that the universe is preparing to reveal something new. The real turning point came as 3I Atlas crossed within 2 astronomical units of the Sun. Even at that distance, twice as far as Earth from our star, sunlight began to seep into ices that had slept for millions of years in interstellar cold. Under that unfamiliar light, ancient chemistry began to stir. The gases did not melt. They erupted, carrying dust and frozen fragments outward to form a coma expanding faster than any model predicted. Rapid brightening often signals instability, but it can also signal revelation. A comet can fracture, dim, or transform entirely when its internal reservoirs first feel the warmth of a new star. With 3I Atlas, the transformation seemed to gather momentum, as if the object were responding to conditions it had never encountered before. Scientists reassured the public that there was no threat. The object would never come closer than 1.8 astronomical units, almost twice the distance between Earth and the Sun. The concern was not collision, it was comprehension. What were we witnessing? This was not a body born in our solar system. Its molecules condensed around a distant star in an environment shaped by temperatures and pressures unlike anything familiar. Now, for the first time, those molecules were being forced to reveal themselves atom by atom in the presence of our Sun. There is a kind of humility in watching something so old undergo its first experience of warmth. It reminds us that even the smallest visitor carries a history older than our species. Tonight, traveller, you and I witness chemistry that has travelled through the dark for epochs, only to awaken in the light of a star it was never meant to meet. But the story grows more tense as the calendar advances. October 3rd marks the close approach to Mars, just 30 million kilometres away. Mars orbiters, with their tireless cameras and unblinking sensors, may record details Earth cannot see: fine structures within the coma chemical fingerprints in the jets, shadows and filaments too subtle for distant observation. And yet, just as the opportunity appears, another challenge rises. The geometry of the solar system places 3I Atlas on a path that soon hides it in the Sun's glare. In early October, the visitor slips into Superior Conjunction, disappearing from the reach of Earth's telescopes. For weeks, during the very moment its activity may peak, when heating fragmentation and chemical transformation reach their highest intensity, the object will be invisible. It is a cosmic curtain drawn at the very moment we most wish to see. Astronomers prepare what they can, models scribbled in the margins of long night spacecraft reoriented. For brief windows of opportunity, spectrographs tuned to capture the faintest possible whispers before the light becomes too bright. But the truth is simple and humbling. The universe will perform its next act in silence, hidden from our eyes, revealing itself only afterward, when the visitor emerges again, changed, perhaps fractured, perhaps brighter, perhaps dimmer, perhaps no longer whole. 3 confirmed interstellar visitors. That is all we have in human history. 3 small emissaries from unknown star systems. Each one has rewritten rules, reshaped theories, challenged assumptions. And this one, this emerald, bright, unpredictable intruder, may be the most revelatory of them all. Tonight, traveller, let this remind you, you are not lost in space. You are part of it. Some mysteries are not meant to be solved, but observed. Somewhere beyond our reach, something ancient still moves, carrying with it a story older than our species and quieter than our understanding. Rest for now. The cosmos will keep watch. As 3 Atlas continued its steady approach toward the inner solar system, the numbers surrounding it took on a life of their own. Astronomers watched them accumulate like quiet footprints across a desert of data, unexpected rises, anomalous curves, brightening rates that felt almost impatient. For weeks, every observatory plotting its light saw the same pattern. The visitor from another star was shedding its silence. Even from millions of miles away, you could sense the tension building in those reports, as if the object itself were preparing to reveal a deeper layer of its nature. And you, traveller listening here in the soft dark, you feel that tension too. You wouldn't be here otherwise. Scientists speak cautiously, but even caution has a tone. Behind their measured words lies a kind of reverent discomfort, the realization that something does not fit, that one of the universe's most ancient messengers is writing over our models with its own quiet handwriting. Each new data point confirmed the brightening of 3i Atlas far beyond expectation. And in astronomy, brightness is never just brightness. It is behaviour. It is chemistry. It is a story rising to the surface. To understand what this means, you have to imagine what lies inside a comet formed around another star. Not ice as we know it, not dust like our dust. But matter born in a distant cradle, another sun, another disk of swirling debris, another set of cosmic conditions. For countless ages, this material drifted in cold so deep that even light seemed to slow around it. Now, for the first time, the visitor meets the warmth of our sun, and something inside it is waking. Astronomers speak of volatile ices, frozen carbon dioxide, carbon monoxide water, and more exotic compounds. But the word volatile hardly captures the intensity of what happens when sunlight touches these materials after millions of years of isolation. They do not simply melt, they erupt. They transition from solid to gas without ever becoming liquid, pushing dust into space, building vast clouds that reflect sunlight with an almost shimmering coolness. When this process speeds up too quickly, comets become unstable. They fracture, they split, they breathe in sudden bursts like geological sighs. But 3i Atlas was doing more than that. It was outpacing the predictions of every model that tried to corral it. The brightness surge was not a gentle incline, it was a leap. From Earth's instruments, the visitor was beginning to resemble a quiet explosion unfolding in slow motion. And yet for all that intensity, it remained impossibly distant, moving with a calm that made its unnatural behaviour feel strangely deliberate. Traveller, think of something sleeping for eons, touched suddenly by warmth, learning again how to expand. When the object crossed the boundary of 2 astronomical units from the Sun, astronomers expected a mild increase in activity. Instead, they saw an acceleration. The numbers suggested more than just heating. They hinted at internal reservoirs releasing themselves in great waves, like stored memory finally finding expression. Some researchers described this moment as the switch on the point where the solar radiation intensity reached a threshold that triggered deeper layers of chemistry long hidden beneath the surface. If that's true, then September of 2025 marked the first true awakening of a fragment from another world. It's tempting to imagine the inside of 3i Atlas as fragile, crystalline, built from materials that have never encountered sunlight. When that first wave of photons struck them, They must have responded with something akin to panic, exploding outward, breaking ancient bonds, transforming dust into light. In the calm language of physics, it is sublimation. In the softer language of the universe, it is exhalation. But there is a subtler meaning hidden in the data. The brightening did not plateau. It did not stabilize, it kept rising, compounding the mystery. And astronomers, even with their decades of caution, began admitting something unusual. The object was not behaving like any comet in our solar system. Imagine standing at the edge of a forest and seeing a shape moving between the trees, one that follows paths you don't understand. You wouldn't be frightened necessarily, but you would be alert, intrigued, humbled. That is the mental state many researchers now find themselves in as they analyse this cosmic visitor. But Traveller, the mystery deepens further when we consider its origin. This object condensed in the disk around another star, forming under temperatures and pressures unlike any we know. It may have drifted between the stars for millions of years, storing the chemistry of its home system in layers untouched by sunlight. Now, under the influence of a new star, those layers are waking for the first time. Whatever emerges, vapours, dust colours, chemical signatures, represents a direct sample of alien formation environments. In a sense, the visitor is unpacking its story as it approaches our star page by page, molecule by molecule. The scientists watching this unfold feel both urgency and awe. They know that 3I Atlas will soon slip into invisibility as it enters superior conjunction. They know the most dramatic changes may occur while it hides behind the sun's glare. They know their models will go dark just as the object enters its most transformative phase. And still they persevere, collecting every scrap of data like quiet notes in a cosmic journal. As the calendar approaches October 3rd, another milestone looms: the close pass with Mars. From the perspective of cosmic distance, 30 million kilometers is intimate. Spacecraft orbiting the red planet may have a chance to see details. Earth will miss subtle jets, chemical shifts, structural hints of internal architecture. A moment like this may never occur again in our lifetimes, an interstellar object moving close enough for our machines to study it not from afar but from the side. But even this moment carries a delicate uncertainty. If the brightening continues or accelerates, the details could be spectacular. If the object's chemistry sputters or dims, the window of opportunity may close before Mars's orbiters can capture anything meaningful. Either way, the encounter represents our only vantage point before weeks of enforced blindness. Tonight, traveller, as you listen beneath the quiet hum of your own thoughts, remember this: you are witnessing the earliest chapters of an unfolding cosmic event. It is not dramatic, not loud, not cinematic. It is slow, alive, and deeply old. And in that slowness lies its power. The universe reveals itself like this, patiently, unpredictably whispering to those who choose to listen. Let this be your resting point for now. We will continue when you're ready. As 3I Atlas swept deeper into the inner solar system, something subtle but profound began to reveal itself in the numbers tracing its path. The orbital mechanics, those ancient equations humanity has trusted for centuries, remained unchanged. Gravity still carved its invisible arcs, and velocity still flowed along predictable lines. Yet even within this mathematical certainty, astronomers felt the quiet emergence of something new. An interstellar object moves differently, carries its own history, its own scars, its own momentum inherited from a star we will never see. A new traveller can almost feel that difference if you listen carefully to the silence between the data points. The trajectory of 3I Atlas was never gentle. It entered our system carrying a hyperbolic excess velocity more than 39 kilometers per second, fast enough to escape the sun entirely after a single swing. Objects born here do not move that way. They are bound to our star, held in orbits that repeat across millennia. But this visitor arrived on a path that spoke of deep time and deeper distances. It had crossed the galaxy not as a wanderer looking for a home, but as a fragment cast outward by forces we may never fully understand. Somewhere beyond our reach, something ancient still moves, and this object is one of its echoes. As it approached the region between Mars and the Sun, its speed climbed steadily under the pull of our star's gravity. By perihelion, it was expected to reach nearly 68 kilometers per second, twice the velocity of Earth, fast enough to traverse the distance from Los Angeles to New York in less than a minute. But the speed itself was not what unsettled researchers. It was the way the object responded to the sun's influence, not gradually, not predictably, but in sudden steps like a sleeper shifting after centuries of stillness. Even the orbit carried hints of peculiarity. A hyperbolic path is normal for an interstellar visitor, but the alignment of 3 Atlas. The way its approach geometry positioned it for a close Mars encounter left astronomers quietly astonished. Random visitors do not often pass near planets. Space is too vast, the angles too unforgiving. Yet this object would cross just 30 million kilometers from Mars, a distance small enough that spacecraft orbiting the Red World would have a front row seat to its passage. Sometimes, the universe arranges a cosmic coincidence so precise that it feels almost deliberate, though the mind knows better than to assume intent. You are not lost in space, traveller. You are part of it. Still, there was something haunting about the timing. The week the object brushed past Mars would be the same week Earth began to lose sight of it. The sun's glare would swallow the visitor just as it entered the most revealing moment of its journey. This is the cruel geometry of conjunction. It blinds us not out of malice, but out of the simple arrangement of orbits Earth the Sun and the comet falling into a line that turns observation into impossibility. Astronomers prepared for this disappearance with the solemn discipline of people accustomed to missing what they most want to see. They calculated solar elongation, the delicate angle separating the comet from the sun in our sky. Once it slipped below 30 degrees, even the most powerful ground-based telescopes would struggle. Below 20 degrees observation would collapse entirely. The light of our star, so gentle when it warms our planet, becomes a floodlight that erases faint objects in its proximity. For weeks, the object would be hidden, its brightest jets, its most violent transformations, its deepest revelations occurring in total secrecy behind a wall of light no instrument on Earth could penetrate. And so astronomers turned their hopes toward Mars, trusting its orbiters to glimpse what Earth could not, the early stages of a metamorphosis unfolding in a region of space where chemistry becomes choreography. The approach to Mars carried more than scientific potential. It carried symbolism. For centuries, Mars has been humanity's mirror, a reminder of how fragile planets can be, how worlds once warm can become deserts, how life may flicker and vanish. To watch an object from another star pass so near the red planet felt like witnessing the crossing of 2 long parallel stories, one planetary, one interstellar. If worlds had memories, Mars might have felt something pass. The predictions for perihelion grew more dramatic as the date neared. At its closest approach to the Sun, 3I Atlas would experience radiation intense enough to trigger deep sublimation chemical upheaval and possibly structural failure. Volatile ices frozen for aeons might erupt in sudden jets, carving canyons in the nucleus, twisting its rotation, amplifying its brightness. Comets can change shape under such stress. Some shatter. Some release multiple fragments that continue the journey like a family of drifting embers. But with 3 Atlas, the models carried more uncertainty than confidence. The composition was unfamiliar. The outgassing rates exceeded norms. The coma was too large, the chemistry too strange, the antitail too persistent. This was not a visitor formed under conditions similar to our own solar system. It was built under another star's light, another star's elemental ratios, another star's gravitational language. To predict its behaviour was to predict the memory of a system we have never seen. In the quiet rooms of observatories, scientists spoke with both awe and restraint. Some stayed late refreshing data feeds, hoping for one more observation before the glare consumed the object. Others worked through the night, updating thermodynamic models with new parameters, trying to understand why the brightness curve kept rising, why familiar equations kept bending. And yet amid all this effort, there was acceptance as well. Acceptance that the universe does not reveal everything at once. Acceptance that some mysteries grow in darkness. Acceptance that observation is a gift, not a guarantee. Tonight, traveller, as you rest beneath a sky filled with objects older than any memory, let this truth settle gently. Some mysteries aren't meant to be solved, only observed. The story of Three Eyes Atlas continues even when we cannot see it. The universe thinks in silence, and it will speak again when the geometry allows. As Three Eye Atlas moved farther inward, the shape of its presence began to blur into something larger than its nucleus. Larger even than the numbers that tried to contain it. Observatories around the world reported something that sounded almost impossible when spoken aloud. The coma, the ghostly atmosphere around the interstellar visitor, was expanding into a size so vast that language struggled to keep up. Night after night, telescopes measured a sphere of gas and dust stretching hundreds of thousands of kilometers, as if the object were exhaling an entire world into the dark. And you traveller listening in the quiet of this moment can imagine it, a faint green-tinged breath drifting through the solar system like a lantern made of air. The coma reached more than 348,000 kilometers, across a size that rivaled half the diameter of the Sun itself. This is not normal, not for our comets, not for any icy visitor born under our star's light. Even the brightest comets in human history rarely build atmospheres so large. Yet this fragment from another star carried enough volatile material, enough internal pressure to sculpt a sphere of gas so immense it could swallow planets whole. When astronomers measured the span of that atmosphere, they had to confirm it twice, then a third time, because some numbers feel too big to believe the first time they appear. But the truth held steady. The numbers were real, and the silence that followed their confirmation felt heavier than usual. For a comet, a coma is more than a cloud. It is a biography. It tells the story of what lives beneath the surface, its chemistry, its temperature, its formation environment. Solar system comets often carry water ice as their primary volatile. But Three Eye Atlas showed something different. Carbon dioxide, carbon monoxide, exotic ices that prefer the coldest regions of star systems, the regions far beyond where our planets were born. Its composition suggested that it formed in a place colder than our outer Kuiper belt, perhaps orbiting a faint red star or drifting in the dim outskirts of a massive blue one. Each molecule in its coma is a messenger from a world we'll never visit. And yet, for all its size, the coma was not the most troubling feature. What caught the attention of every scientist, every amateur observer, every person who watched the images appear across the internet was the shape of its tail, or rather the direction it pointed. Tails should always point away from the sun. Radiation pressure pushes gas outward in long, glowing arcs. Dust follows magnetic lines spreading like faint smoke. But Three Atlas developed a plume pointing toward the sun, as if defying the most basic rule in cometary physics, an anti-tail astronomers call it. Rare but not unheard of. Dust can behave strangely when viewed at certain angles, when the geometry between the observer, the sun and the comet aligns just right. But this anti-tail persisted. It grew. It sharpened. It behaved as though a force or a pattern within the comet was pushing material sunward intentionally. Not literally with purpose, but with physics we could not yet explain. And so, the debates began. Dust sizes too large for radiation pressure. Rotational jets angled perfectly plasma fields, shaping the dust like invisible fingers. Each explanation was plausible. None were comfortable. Listener, this is where the universe invites humility. Not fear, not fantasy. Just the soft acknowledgement that we do not yet understand everything it is capable of. The expansion of the coma followed a rhythm unlike any seen in local comets. Gas velocities higher than expected. Temperature readings that suggested deeper, faster heating. Molecular signatures forming in patterns that hinted at reactions still unknown, or at least unobserved within our system. It was as though layers buried for eons were peeling away one at a time, revealing the chemical inheritance of another star. Jets streamed from the nucleus in the irregular bursts, carving faint arcs into the expanding gas. Each jet told a story of pressure, of internal fractures, of volatile pockets bursting outward. In the quiet language of physics, it was simply outgassing. But in the softer language of wonder, it felt like the visitor clearing its throat after a journey across the galaxy. Dust grains within the coma carried their own secrets. They were larger than expected, too large to be pushed easily by sunlight. When they interacted with solar radiation, they created shadows, curves, ripples, and subtle textures across the cloud of gas. The anti-tail, that strange sunward plume, may have been born from this dust, large particles moving on trajectories that light could not dominate. But the persistence of the structure raised questions that researchers still whisper about late at night. Why so stable? Why so bright? Why so directional? Even the heating patterns revealed something unusual. Infrared measurements showed temperatures inconsistent with standard solar absorption. Something else was contributing molecular reactions, chemical transformations, perhaps the release of energy locked within crystalline structures shaped in another star's nursery. Some part of the comet seemed to remember a different sun, a different environment, and its chemistry responded not with simplicity but with complexity. As the coma thickened and brightened, observers reconstructed its three-dimensional form. It was not a sphere. It was a landscape layered directional, filled with cavities and ridges, created by jets erupting from specific regions of the nucleus. These patterns suggested that the rotating core was not uniform. Some areas were rich in volatile ices, others were crusted dormant, perhaps ancient scars from collisions in the long interstellar dark. Rotation models tried to catch the rhythm, but the comet refused to reveal a clear period. Its light curve was irregular, shifting, evolving with each new wave of activity, and traveller, that is the quiet truth. We were and still are watching something learn how to be warm. Interstellar comets do not carry the tidy predictability of local objects. They are shaped by cosmic environments we cannot replicate. Tides of radiation, dust storms drifting between stars, the cold of regions where time itself seems to slow. 3's East Atlas is a survivor of those places, and now under the influence of a different star, it is undergoing transformations that science has never fully catalogued. As it approaches its critical encounters with Mars with the Sun, with the geometry of conjunction, its coma will continue to evolve, expanding, glowing, reshaping itself around pressures we cannot see. Some changes may occur in darkness during the weeks when Earth loses sight of it entirely. Some revelations may never reach us, and that listener is part of the mystery. Some stories unfold even when no one is watching. Some transformations require privacy. Some truths belong to the universe alone. The change happened quietly at first, the way most cosmic transformations do. A faint shift in colour, a subtle alteration in the way light moved through the coma. Then, almost overnight, 3i Atlas began to glow with a soft, unmistakable green. Not the gentle green of earthly life, nor the artificial green of instruments and screens, but something colder, older, drawn from molecular structures shaped under the light of another sun. It was a shade the universe rarely paints reserved for special moments when chemistry steps forward to speak through light. Observers noticed it in early September when telescopes captured images under unusually dark skies. At first, the green seemed like a photographic quirk, an artifact of sensor settings or atmospheric filters. But night after night, the colour deepened, consolidating around the nucleus like a luminous thought slowly forming. It grew brighter during the lunar eclipse of September 14th, when Earth's shadow allowed astronomers a rare, unobstructed view. Under that deepened darkness, the glow did not hide. It revealed. The cause, at least at first glance, seemed simple enough: diatomic carbon, the C2 molecule. When bombarded by ultraviolet light from our sun, C2 fluoresces with an emerald shimmer. In many comets, this glow is a common signature. Yet, in 3i Atlas, the story was more tangled. Early spectroscopic data from James Webb and ground-based observatories showed little evidence for carbon-bearing molecules beyond carbon dioxide. The chemical puzzle lay in plain sight. The green emission was strong, but the molecular precursors seemed insufficient. This contradiction prompted quiet conversations among researchers. Some proposed that deeper layers of carbon-rich material had only recently begun to outgas as the comet crossed a thermal threshold near 2 astronomical units. Others wondered if the carbon-bearing molecules existed in forms not easily detected by standard spectroscopy, larger organic chains or refractory compounds that broke apart only after prolonged ultraviolet exposure. And some simply admitted that the chemistry of an interstellar object might not map cleanly onto the behaviours observed in local comets. Whatever its origin, the green glow told us that new chemistry had awakened on the comet's surface. Carbon dioxide ice abundant in 3I Atlas may have undergone photodissociation, the breaking of molecular bonds under sunlight producing carbon monoxide, atomic oxygen, and eventually free carbon atoms. When those atoms combined into diatomic carbon, a resonance emerged, a quantum dance between electrons that emitted light at 516 nanometers, a wavelength the human eye perceives as green. To understand it, listener imagine the nucleus as a dark memory untouched for millions of years, suddenly exposed to a warmth it has never known. Molecules fracture, atoms recombine, bonds reconfigure into shapes that vibrate with light. What we see from Earth is merely the surface signature of deeper transformations, chemical processes working their way through layers that have rested in cosmic silence since the object's birth around another star. As the green intensified, it began to fill the coma unevenly. Some regions were brighter than others, forming gradients, pockets, and drifting veils of colour. These irregular patterns hinted at uneven outgassing jets, fissures, or fractures hidden beneath the dust cover. Heat does not penetrate a nucleus uniformly. It finds weak points, soft patches, old wounds from collisions in the interstellar dark. When it reaches volatile-rich areas, the resulting outburst paints the coma with sudden bursts of molecular light. The non-uniform glow also suggested internal complexity. Comets from our solar system often contain layered structures formed during slow accretion in the protoplanetary disk. But 3I Atlas forged under foreign conditions may have assembled differently, incorporating materials unknown to our environment, organics shaped in colder regions, exotic ices, particles of dust altered by cosmic rays. Its colour changes reflect not just current solar radiation, but the ancient chemistry imprinted upon it. Scientists studying the evolution of the glow noted fluctuations that did not sync with simple distance or heating curves. Some nights the green brightened unexpectedly, on others it faded slightly or shifted into different hues along its edges. These fluctuations suggested dynamic reactions within the coma molecules, breaking, recombining, scattering and cooling in patterns impossible to capture with simple models. For the viewer, the glow was a tranquil beauty. For the physicist, it was a restless equation. And yet, even in its complexity, the glow carried a message: this interstellar visitor is not static. It is alive, not biologically, but dynamically responding to our sun with chemistry that remembers another world. A world with its own rules, its own temperatures, its own rhythms of radiation and darkness. Every interstellar object observed so far, Oumuamua, Borisov, and now 3I Atlas, has displayed some behaviour that broke from expectations. Oumuamua showed no visible outgassing, yet accelerated as if pushed by invisible forces. Borisov behaved like a normal comet, but carried chemical fingerprints unknown in our solar system. And now, 3I Atlas glows green in ways that do not match its measured composition. Each anomaly is a reminder that our solar system is not the universe. It is only one neighbourhood, a quiet one perhaps, a predictable one, but not a complete one. As 3I Atlas moves closer to the Sun, the glow may continue evolving, brightening near perihelion, shifting in colour as new molecules become active or fading as others become depleted. Some of these changes will occur during the weeks when Earth can no longer see it when it slips behind the Sun. During that time, the comet will experience temperatures and radiation levels capable of reshaping its chemistry once again. The green glow may intensify into something even stranger, or vanish entirely as volatile stores exhaust themselves. And this is where the universe reminds us of our limitations. We watch what we can, we infer what we must. But some transformations unfold in darkness beyond telescopes, beyond sensors, beyond the persistent curiosity of humankind. It is not unfairness, it is simply the nature of cosmic timing. Through all of this, the glow of 3I Atlas serves as a mirror. It reflects our desire to understand, our tendency to wonder, our acceptance that some mysteries may remain just beyond reach. It reminds us that the universe is not obligated to reveal itself fully, and that in the vast space between stars, molecules carry histories older than Earth, older than our Sun, older even than the language we use to describe them. Tonight, traveller, imagine that faint green light drifting across the void, a shimmering breath from another star. Imagine chemistry stirring like memory, Imagine a story written in wavelengths slowly unfolding under a sun it has never known. And remember, some mysteries aren't meant to be solved, only observed. Rest now. As 3I Atlas drifted closer to the sun, a new barrier emerged, one not made of physics but of geometry. The comet had begun revealing the most intriguing pieces of its story: the rapid brightening, the impossible coma, the unsettling green glow. Yet just as these transformations accelerated, Earth's telescopes found themselves slowly blinded. It was not malfunction nor failure. It was simply the alignment of celestial bodies following paths older than human memory. To observe the universe is to accept its timing, and its timing does not bend for us. As the comet approached the sun from Earth's perspective, the angular separation between the two grew painfully small. The world's most advanced telescopes' machines of mirrors, sensors, and liquid nitrogen-cooled detectors were powerless against the oldest obstacle in observational astronomy: sunlight. The comet's light dimmed not because it faded, but because it drowned in brilliance. Even the faintest scattering of sunlight in Earth's atmosphere washed out the signal entirely. To astronomers, it was like watching a lantern drift toward a rising dawn. You can follow it only until the sky brightens. After that, no amount of straining will return the glow. By early October, when 3I Atlas had barely begun unveiling its true chemistry, it crossed the 30-degree elongation threshold, a point at which ground-based observation becomes difficult even for experts. By mid-October, the elongation dropped below 20 degrees, and the comet effectively disappeared from Earth's sky. It did not vanish in any dramatic sense. It simply dissolved into daylight, a cosmic sleight of hand. Nothing was wrong with the instruments. The problem was sunlight itself. Professional observatories equipped with adaptive optics and enormous mirrors could detect galaxies billions of light years away, yet they could not isolate a small faint object standing too close to a star. Even space-based instruments were bound by similar restrictions. Telescopes like Hubble and James Webb cannot risk exposure to direct sunlight. Their sensors would be damaged instantly. They rely on carefully planned angles, safe pointing zones, and mechanical shields. A comet drifting near the sun is like a whisper spoken next to a roaring fire. The whisper cannot reach you no matter how attentive you are. So traveller astronomers accepted a difficult truth: the most important chapter of 3I Atlas's story would unfold where no human eyes nor human machines could follow. And that realization stirred something bittersweet in the scientific community. Excitement, because the comet was approaching its most volatile phase. Frustration, because they would miss much of it. Humility, because the universe is under no obligation to time its revelations around our convenience. This temporary blindness produced another effect, a rare dependence on machines not orbiting Earth but orbiting Mars. As 3 Atlas approached its close pass with the Red Planet spacecraft circling Mars, suddenly became humanity's proxy observers, not because they were designed for comet science, but because they happened to be in the right place at the right moment, a coincidence written into the geometry of two worlds. But even with Mars as a backup vantage point, the period of superior conjunction remained unavoidable. The comet would slip behind the sun from our perspective and remain there for weeks. During that time, its chemistry would evolve rapidly. Volatile materials would ignite, the coma would expand, jets might erupt. Fragmentation, if it were to happen, would occur here in this bright hidden corridor. Astronomers could only wait. And waiting is its own science, its own form of discipline. It is also a confrontation with helplessness, something researchers seldom acknowledge openly. They study the stars because observation gives them power to understand, to predict, to decode. But during conjunction, that power quiets. The universe simply continues indifferent to our desire to see. In this enforced darkness, data scattered across September and early October took on new weight. Every spectrogram, every brightness reading, every image of the green coma became a relic clues pointing toward transformations occurring beyond view. Scientists pored over them, as if translating a language with missing letters. They refined models, ran simulations, compared thermal curves, debated chemical pathways. They tried with quiet urgency to predict what would happen, while human observation was suspended. Some suspected the brightening trend might peak dramatically during the hidden weeks. Others thought the comet could fragment, splitting into multiple pieces under thermal stress. A few wondered if the anti-tail structure would evolve into something entirely new, an architecture of dust and plasma sculpted by the intense solar wind. But all predictions carried the same disclaimer: we won't know until the comet returns. During this forced silence, a philosophical mood spread through the astronomical community. Conversations at observatories ended in phrases like, "We'll see," or "if it survives," or "the universe will tell us in its own time." There was a sense of surrender, not defeat, but acceptance. A pause. A recognition that no matter how advanced our technologies become, we remain creatures bound to a single point in space, peering outward with limited angles and imperfect reach. You can learn much from the sky, listener, but sometimes the sky asks you to wait. And behind all the frustration there was wonder, the kind that humbles you, the kind that curls gently into the mind during late-night observation sessions when the dome opens and cold air rushes in, the kind that reminds you that no instrument, no calculation, no model can fully anticipate what a cosmic visitor might do when it meets the sun for the first time. As 3i Atlas moved deeper into the glare, astronomers whispered a final thought before the silence. Whatever happens next is happening now. And then, like a story closing mid-sentence, the universe turned the page for us. Tonight, traveller, breathe gently. Some mysteries must unfold beyond our sight, and that is part of their beauty. There is a particular silence that settles over an observatory when something begins to disobey expectations. It is not the silence of calm, but the silence of thinking. The kind that fills the air when scientists stare a little too long at their screens, when the numbers do not follow the curve they were supposed to trace. And over the last weeks, to traveller, that silence has been spreading across research centres around the world. Astronomers do not panic easily. They have watched stars die, supernova remnants expand, and galaxies collide over cosmic timeframes. They are trained to expect the unexpected, but even they are beginning to admit with careful language and measured caution that 3i Atlas is behaving in ways that none of their models prepared them for. In quiet meetings and email threads sent at absurd hours, a new phrase has started to appear. We may be witnessing something unprecedented. What unsettles them is not one anomaly, but a convergence of many. The brightness curve is the first and loudest clue. Observers everywhere, from amateur astronomers watching from backyard telescopes to global networks like the Comet Observation Database, have recorded the same pattern. 3i Atlas is brightening too fast, too early, too dramatically. And when independent systems agree, when data sets align across boundaries of geography and equipment, scientists know the universe is insisting on being heard. Normally comets brighten as they near the sun, shedding volatile materials in predictable rhythms. But 3i Atlas is brightening outside of those rhythms, rising several magnitudes above the expectations drawn from standard comet physics. It is not the gentle upward slope of warming ice. It is a spike, a sudden inhalation, a change that feels more alive than mechanical. To a scientist, brightness is not just light, it is behaviour to temperature chemistry and structural tension all speaking at once. The September surge suggests processes unfolding deep within the nucleus happening faster than thermal models allow. Something inside 3i Atlas may be awakening, cracking open, releasing material in bursts rather than steady breaths. And so, the scientific language begins to shift. Researchers start using words like anomalous, accelerated, nonlinear. These words are quiet, but they are heavy. They imply not confusion, but limits the edge of what human theory can currently describe. Then comes the second clue, the antitail. Every comet in the solar system obeys the same basic principle. Solar radiation pushes dust and gas away from the sun, creating tails that stretch outward like luminous wings. But 3i Atlas has developed a structure pointing in the opposite direction, a plume leaning toward the sun. Even among the rare comets known to form anti-tails, this one is unusual, too defined, too persistent, too geometrically precise. Some astronomers whisper that it looks more like a jet than a plume, a deliberate outflow of material instead of a passive reaction to heat. Others suspect a dust grain size distribution so unusual that it has never been observed before. Still, others propose rotation states or thermal patterns so exotic that they would require rewriting cometary physics. But no one agrees, not yet. And underneath these professional disagreements rests an emotion scientists rarely voice awe. Because to witness a sunward plume on an interstellar object is to glimpse a form of behaviour we have never seen in anything born near our sun. It is a signature of origin, a hint that 3i Atlas carries chemical memories from a place where stars form differently, where temperatures and materials dance to rules unfamiliar to our own. The green glow adds another layer of mystery. In September, the comet shifted into an eerie emerald hue, diatomic carbon, fluorescing under ultraviolet radiation. Under normal circumstances, this glow emerges from carbon-rich materials shedding molecules in sunlight. But earlier spectroscopy suggested that carbon-bearing compounds were not abundant enough to create such a luminous display. Something does not add up. Either our instruments missed key molecules, or the chemistry within the coma is far more dynamic than anyone anticipated. Perhaps new materials are being exposed as the comet heats. Perhaps the green is not static, but part of a larger chemical story unfolding molecule by molecule, layer by layer, as sunlight peels back materials untouched for millions of years. In late-night discussions, scientists wonder whether the early September brightening triggered the green emission, as if the comet passed a threshold, a temperature at which ancient carbon structures finally woke and began responding to solar radiation in a way we have never documented before. But this is speculation, and speculation is always tempered with caution. Astronomers prefer evidence. Yet with 3 Atlas nearing the sun, evidence is disappearing into glare. This uncertainty creates a quiet tension. It is not fear, not the fear of threat, but the fear of missing something meaningful, something that might happen only once in human history, something that might never be observed again. In online forums and professional channels, researchers share tentative conclusions, blurry images, refined light curves. They remind one another to remain skeptical, to avoid overinterpretation, to trust only what the data supports. Yet beneath these layers of caution lies a shared feeling. We do not fully understand this object, not yet. Amid the excitement, there is humility too. With only 2 interstellar objects previously observed, Oumuamua and Borisov, humanity has barely begun to understand the diversity of worlds wandering between stars. Each visitor has behaved like a rule breaker. Each one has forced scientists to invent new explanations. And now 3i Atlas arrives with its green light, its sunward plume, its staggering coma, its accelerating brightness, as if to remind us that the universe is far stranger and richer than our models predict. Astronomers know they are standing in the early dawn of a new field. Every observation is precious. Every anomaly is a teacher. Every unanswered question is an invitation. And as the comet slips into solar glare as Earth prepares to lose sight of it, for 4 long weeks, a final thought settles across observatories like a soft collective breath. Whatever 3i Atlas is becoming, it is becoming now. Tonight, listener, rest in the knowledge that even our uncertainty is a kind of wonder. Sleep well. The universe is still thinking. As 3i Atlas drifted into the narrowing gap between Mars and the Sun, a quiet shift took place in the way humanity observed it. Earth, blinded by sunlight, gradually lost its ability to see the visitor. But Mars, positioned differently in its orbit, became an unexpected vantage point, a silent witness to a moment Earth could not access. And so, for a brief window of cosmic alignment, our machines circling the red planet became our borrowed eyes. The orbiters around Mars were not designed for comet watching. They were created for geology, climate, atmospheric chemistry, and mapping ancient river channels carved into the Martian crust. Yet suddenly, these spacecraft Mars Express, Marvin ExoMars TGO, and the long-lived Odyssey were asked to look outward instead of downward. Because the universe does not wait for ideal instruments. It reveals what it chooses when it chooses. From Mars's perspective, 3i Atlas did not vanish into solar glare as quickly as it did from Earth. The planet's different position gave its orbiters a clearer angle, not perfect, but valuable. And in astronomy, even a few extra degrees of visibility can reveal entire chapters of a phenomenon's evolution. The comet's green glow lingered longer against the Martian sky, its shape more defined, its activity more legible. As the comet approached its closest distance to Mars, its coma swelled into something vast and ghost-like. Dust and gas enveloped the nucleus in layers that shifted with sunlight, forming veils and arcs that moved as if stirred by soft wind. The anti-tail, the mysterious plume pointing toward the sun, instead of away, sharpened into a distinct streak startlingly geometric. Through the sensors of orbiters, the structure looked almost sculpted, as if the dust grains were obeying rules unknown to familiar cometary physics. These observations produced mixed reactions among scientists. No one wanted to claim anything extraordinary. Caution is the backbone of the scientific method. But even the most measured voices admitted that the images contained features not easily explained. Some spoke of dust dynamics behaving unusually under the solar wind. Others suggested a rotational jet angled so precisely that it mimicked intention. A few whispered that interstellar comets might carry structural or chemical properties that defy expectations entirely. Below the orbiters, the Martian rovers continued their slow work on the ground, unaware of the cosmic visitor passing overhead. Yet their cameras at times caught faint streaks of motion in the thin Martian atmosphere, streaks that amateur analysts later identified as possible fragments or reflections from 3I Atlas's activity. One frame contained a flash of green that appeared in a single instant and vanished just as quickly. It could have been an imaging artifact. It could have been sunlight glinting off material in the coma. On Mars, truth and ambiguity often share the same pixel. When the comet reached its closest point to the red planet, the orbiters captured a range of data that scientists are still analysing. Some instruments recorded faint pulses within the coma, subtle variations in density or brightness that suggested internal waves of activity. Others detected changes in ultraviolet reflectance, hinting at molecular processes accelerating under solar heating. The trace gas orbiter designed to study Martian atmosphere detected unexpected gas signatures that did not align neatly with carbon dioxide alone. All of these clues were small, incomplete, quiet, but together they suggested a deeper complexity unfolding inside the expanding cloud of dust and ice. None of the spacecraft saw anything definitive, but every one of them saw something unusual. More puzzling than the images was the behaviour of the comet's brightness. Mars-based observations showed fluctuations that did not match simple thermal models. The glow brightened, then dimmed, then reformed. Jets appeared and dissolved. Structures in the coma shifted in hours rather than days. Even the green fluorescence of diatomic carbon showed variations that hinted at evolving chemistry. It was as though the comet was reacting to its environment, dynamically adjusting to stresses it had never experienced. Not alive, not conscious, but responsive in the way complex systems can be when exposed to extreme conditions for the first time. The sun was triggering behaviours encoded in the comet's structure long before it entered our solar system. As Mars continued to observe, Earth received the data through slow radio transmissions, fragmented packets, travelling across millions of kilometres of empty space. Each downlink brought glimpses, hints, silhouettes of behaviour. And with each transmission, a quiet urgency grew, because everyone knew the window was closing. Mars too would soon lose sight of the visitor, as it slipped deeper into the blinding proximity of the sun. Once the angles shifted, no spacecraft, not Earth-based, not Mars-based, would be able to see 3I Atlas at all. And so the moment came when humanity became blind again, just as the comet entered its most volatile phase. Behind the curtain of sunlight, ices would crack, jets would erupt violently, dust would billow into space. Chemical transformations invisible to us would unfold under radiation thousands of times stronger than the comet had ever encountered. This hidden phase stirred both awe and frustration among astronomers. Awe because the universe was writing its next chapter in a place no one could witness. Frustration because this chapter might contain the answers to questions that had consumed scientists for months. But frustration softens traveller when one remembers the nature of cosmic timing. The universe is older than our impatience. It reveals itself only when it chooses. During the blindness of conjunction, researchers turned to prediction. They simulated thermal cracking sublimation jets and rotational instabilities. They debated whether the nucleus would fragment. They wondered whether the green glow would intensify into a halo or fade entirely. They speculated about the fate of the anti-tail. Would it straighten, curl, break apart? No one knew. No one could know. And strangely, that uncertainty brought a kind of peace. A reminder that even in an age of powerful telescopes and interplanetary spacecraft, there are still moments when nature demands humility. Some cosmic events must unfold unwitnessed. And when 3i Atlas finally emerges again from behind the sun, altered or unaltered, bright or diminished, intact or fractured, it will carry the imprint of everything that happened while humanity waited in silence. To Night Traveller. Rest in the understanding that mystery is not the enemy of knowledge, it is the beginning of it. As October deepens, a quiet inevitability settles over the astronomical world. 3i Atlas continues its inward drift, and with every hour the geometry between Earth, Sun and Comet shifts into a configuration that no telescope, no observatory, no instrument can overcome. The visitor is sliding into Superior Conjunction, a cosmic hiding place carved not by intention, but by simple inevitabilities of orbital motion. For earthbound observers, it begins subtly. The sky near the sun grows brighter, bluer, washed with scattered light that overpowers even the faintest stars. The comet, once cleanly separated from the sun in early September, now seems to slide closer to the solar glare like a firefly drifting too near a floodlight. And then little by little, even the most powerful telescopes begin to lose their grip on its faint outline. The loss is not dramatic. It is gradual, almost tender, like watching a candle being carried down a long hallway, dimming step by step until only the memory of flame remains. Professional observatories extend their observations longer than amateurs can, pushing their instruments toward the edge of brightness, where physics becomes unforgiving. But eventually even they must surrender. The sky wins, the sun wins. By mid-October, 3i Atlas simply becomes unobservable, not gone, not extinguished, only hidden, held behind a curtain of light woven by our own star. Superior Conjunction is a simple geometry. Nothing mystical is required to explain it. Yet its consequences feel strangely personal to those who have spent months watching this object evolve. When the comet enters the region of sky too close to the sun for safe observation, Earth-based astronomy becomes blind. Solar photons scatter through the atmosphere, washing out faint signals, drowning spectroscopic signatures, collapsing the delicate shapes that telescopes try to extract from the glare. It is astronomy's most ancient limitation, unchanged by centuries of innovation. You cannot see what sits in the direction of the sun. And so, traveller, we enter a period of enforced silence. The timing is ruthless. Superior Conjunction arrives exactly as 3i Atlas reaches the most violent stage of its solar encounter, the week surrounding perihelion, when heating rises to its peak and the comet's internal chemistry becomes most unstable. Every model predicts that this period should reveal its deepest secrets, its structure, its compositions, its behaviour under stress. And yet these secrets unfold where we cannot look. Imagine the coma at that moment. Jets of gas erupting like fissures splitting open in an ancient stone. Dust streaming into space at tens of thousands of kilometers per hour. Carbon compounds fluorescing under ultraviolet radiation. Ice structures cracking, collapsing, reforming. The nucleus absorbing heat it has not felt since its birth in another star system far beyond the sun's reach. All of it happening unseen, a private transformation enacted behind a wall of light. This is the true ache of Superior Conjunction, not simply that the comet disappears, but that it disappears during its metamorphosis. Astronomers speak of this period with frustration wrapped in awe. They know what should be happening. They can predict broad outlines, sketch thermal responses, simulate outgassing rates. But prediction is not observation, and in science, witnessing matters, data matters, seeing the moment matters. Instead, all humanity can do is wait. As the comet sinks deeper into the solar glare, other complications arise. Even spacecraft cannot always help. The James Webb Space Telescope with its delicate sunshield cannot safely point anywhere near the sun. Hubble too must avoid orientations that threaten its optics. Solar observatories equipped with coronagraphs might capture a glint of dust or a trace of tail, but only if the comet wanders close enough to their narrow fields, and 3i Atlas does not. For several weeks, Earth becomes cosmically deaf. During this silence, astronomers gather the last fragments of data from early October and attempt to extrapolate. They debate the meaning of the sudden brightening. They revisit the anti-tail geometry. They question whether the nucleus is stable enough to survive perihelion. Their conversations take on a twilight tone, part analysis, part imagination, part longing for the sky to clear in a direction it never will. Meanwhile, the comet continues indifferent to being watched. It approaches the Sun with speeds exceeding 150,000 miles per hour. Its coma expands into a sphere so large it could swallow planets whole. Its carbon dioxide jets burn like invisible torches in the ultraviolet spectrum. Its internal fractures spread. Its dust grains collide in microgravity, spiralling into new shapes. And all of this takes place in a silence so complete that even our best instruments cannot record it. Superior conjunction also plays a psychological role. Researchers speak openly of the cosmic cliffhanger, the sense that they have reached the final chapter of a story only to have the last pages sealed shut. It is a reminder of how small human perspective remains even after centuries of astronomical advancement. The universe does not pause its motions for our convenience. There is humility in that realization, and a strange kind of peace. Because hidden does not mean lost. What happens during conjunction will eventually reveal its consequences. The comet will reappear in November or early December, emerging from behind the Sun, altered or unaltered, bright or dim, fragmented or whole. Whatever perihelion has done to it, the evidence will linger, etched into the new shape of its coma, written into its evolving brightness curve, folded into its changing tail geometry. All of these clues will tell the story retroactively like footprints in cosmic dust. And so, Traveller the Wise responses patience, the virtue astronomy has always demanded. Even now, as we lose direct sight of this visitor, the universe continues its quiet work. Somewhere behind that blinding curtain, something ancient and fragile moves through the heat of a star it has never met before. The universe whispers again even when we cannot hear it. And in this interval of silence, it's all right not to understand. It's all right to wait. It's all right to rest. Sleep now, traveller. The cosmos will keep watch until Three-Eye Atlas returns. There comes a moment in every cosmic story, traveller, when the pace of the universe seems to quicken, even as our ability to observe falls away. For Three-Eye Atlas, that moment is perihelion, the instant it sweeps through its closest approach to the Sun, racing through a furnace of radiation unlike anything it has experienced in its long journey between the stars. And though this moment may shape its entire destiny, we on Earth will witness none of it. The comet will pass through its transformation, hidden behind the blur of daylight, as if the universe has chosen to let its metamorphosis unfold in private. At perihelion, the physics becomes almost overwhelming. The speed of Three-Eye Atlas climbs towards 68 kilometers per second, more than twice the orbital speed of Earth. At such velocity, the laws of motion become visceral. The comet is not simply moving. It is plunging, carving through the Sun's gravity well like a stone skipping across a blazing ocean of light. Kinetic energy accumulates in every atom of its nucleus, and even the vacuum around it begins to shimmer with the glow of ionized gas. Imagine that, listener. Something older than our species rushing toward the most intense light it will ever know. Every volatile locked inside it begins to stir carbon dioxide, carbon monoxide, and deeper ices that have been frozen since another star lit the sky of its birth system. Perihelion is not just a point on a diagram. It is an awakening of chemistry millions or billions of years old. If you could see it, if Earth were not blinded by the Sun, the coma might swell in real time. Dust would boil off the surface. Jets would erupt from cracks that have lain dormant since interstellar night. A tail could bloom like a slow-moving flame tens of millions of kilometers long. But instead we must rely on inference mathematics and imagination. During perihelion, Three-Eye Atlas slips behind the Sun, leaving us to wonder what happens to an interstellar traveller under the heat of a star it never meant to approach. The rapid heating introduces stress deep within the nucleus. Comets are fragile things, collections of dust, ice voids, and ancient grains, fused together by the gentlest of forces. When the temperature rises too quickly, the balance shatters. Subsurface pockets of gas erupt outward like tiny volcanic blasts. This process has broken many comets, before turning them into cascades of fragments, drifting behind invisible lines of gravity. Whether 3I Atlas can survive this ordeal is one of astronomy's quiet questions. Its composition is unlike anything we've seen dominated by carbon dioxide rather than water. That unusual chemistry could make it either more resilient or more vulnerable. And because the comet moves so quickly, the period of maximum heating is brief, a harsh flash rather than a slow burn. Some researchers believe this short duration increases its chances of survival. Others think the rapid change may shatter it more easily. All we can do is wait for its return. Another mystery lies in the changing shape of the coma. Before disappearance, its atmosphere had already grown to unprecedented dimensions large enough to rival half the diameter of our Sun. Near perihelion, such a coma might evolve into something even stranger, expanded by violent outgassing sculpted by solar wind, twisted by magnetic fields into forms we can scarcely model. Dust grains may realign, plasma may ripple along invisible field lines, new volatiles may ignite colours we have not yet seen, and the anti-tail, that unusual sunward plume, may intensify or vanish. If it is driven by slow rotation, perhaps it grows even sharper under the sun's touch. If it is driven by dust size, perhaps it becomes unstable and breaks apart. Or perhaps, as some speculate in quiet conversations entirely new, tail structures could form signals of volatile species never before observed in interstellar comets. But none of this is visible to us. The sun overwhelms every attempt to observe these processes directly. Even spacecraft designed to study comets cannot safely point so close to the solar glare. Instruments like Hubble and Webb must turn away. Solar probes cannot orient themselves toward the path 3I Atlas takes through the inner system. For weeks, the interstellar visitor exists in a place where human eyes, mechanical or biological, cannot follow. And so Traveller the story continues in silence. Yet silence in astronomy is not emptiness. It is simply the universe thinking in its own long rhythm. While we cannot watch perihelion unfold, its consequences will be inscribed into every particle the comet carries when it re-emerges. If the nucleus fractures, we will see it as multiple points of light. If new jets ignite, we'll see the changing brightness curve. If the coma expands beyond previous records, we will see its reach in recovered images. This is the strange romance of astronomy. The most important moment in a comet's journey may be invisible, yet its effects echo far beyond the veil. As the comet passes perihelion, it will begin decelerating. The sun's gravity, which accelerated it toward this fiery meeting, now slows it as it departs. The switch is subtle but fundamental, a reminder that every approach must eventually become a retreat. And perhaps that is the metaphor, listener. Nothing approaches light without being changed by it. In the weeks after perihelion, when it emerges from conjunction, the comet may appear dimmer or brighter. It may have grown quiet or exploded into drama. It may be familiar or transformed. Whatever shape it carries then will tell the story of everything we could not witness. This is the nature of cosmic observation moments of sight, followed by necessary intervals of trust. So let the mind rest. Let the unknown settle softly. Nights like this remind us that some transformations are meant to happen unwatched, shaped by forces older than memory. You are not lost in space, traveller, you are part of it, and the universe will turn with or without our gaze. Every interstellar visitor that has crossed our sky, traveller, has left behind more questions than answers. And as we follow the strange behaviour of 3I Atlas, it becomes necessary to look backward, not out of nostalgia, but because the universe rarely repeats itself. Each arrival carries its own language, its own physics, its own quiet defiance of what we think we know. Tonight, as you listen, let the past drift beside you like a constellation of distant memories. The first visitor, Oumuamua, appeared in 2017, like a word spoken too softly to understand. It had no coma, no tail, no familiar signature of sublimating ices. It slipped through sunlight without so much as a whisper of vapour, and yet something pushed it a small non-gravitational acceleration that confused everyone who tracked it. Some called it outgassing so subtle it escaped every instrument. Others wondered if its unusual shape, long and thin, made it unusually susceptible to radiation pressure. Others quietly in the corners of conferences imagined more exotic ideas. But Oumuamua never lingered long enough to illuminate its own mystery. It simply passed through like a thought the universe decided not to finish. 2 years later came 2I Borisov carrying a different kind of message. Borisov behaved more traditionally a visible coma, a familiar tale, but its chemistry betrayed a foreign childhood. Carbon monoxide levels higher than a local comet. Dust and ice mixtures unlike anything orbiting our sun. It was as if Borisov had been shaped in a colder nursery, under a dimmer star, or perhaps in a disk richer in carbon than ours. Even in its apparent normality, it whispered of other solar systems, other conditions, other beginnings. And then, after a long silence, came Threes Atlas. Not subtle like Oumuamua, not conventional like Borisov, but something wholly other. Its coma is larger, its chemistry more extreme, its behaviour more unpredictable. Where the earlier visitors offered hints, Atlas feels like a declaration. If Oumuamua was a question, and Borisov an answer, then Atlas is a story unfolding in real time, one written in alien ices and sunlight. The diversity of these three objects is remarkable. Nothing about them rhymes. Their shapes, compositions, behaviours and brightness curves refuse to fit a single model, and perhaps that is the quiet lesson the galaxy is offering us. Interstellar objects are not a category but a population. A vast archipelago of wanderers shaped by 1,000 suns, 1,000 chemical histories, 1,000 gravitational accidents strewn across the Milky Way. It is humbling, isn't it, listener? We once imagined comets as simple things, icy leftovers from planetary formation. But now the universe shows us that even leftovers can carry entire cosmologies within them. Consider the way each object reflects its birthplace. Oumuamua, seemingly devoid of volatiles, may have formed in a region where ices were scarce or stripped away. Borisov, rich in carbon monoxide, suggests formation in a disk so cold that CO froze abundantly. And 3I Atlas, with its carbon dioxide-dominated coma, may have condensed in an environment even more exotic where CO2 rather than water, or CO, defined the chemistry of early planetesimals. Such diversity challenges our assumptions. We once believed our solar system's structure, its warm inner planets, icy outer regions and vast reservoirs beyond represented a kind of cosmic default. Yet these visitors reveal that planetary systems may vary dramatically in temperature density, chemical composition, and stellar radiation. Our system is not the blueprint, it is simply one example. This realization shifts something deep within the scientific mind. It reminds us that the galaxy is not standardized. It is improvisational, chaotic, creative. And these objects drifting between stars are the messengers of that creativity. Kinematics add their own layer to this cosmic conversation. Oumuamua arrived with a hyperbolic excess velocity of around 26 kilometers per second, already higher than most long-period comets. Borisov arrived faster still, around 32 kilometers per second. But 3I Atlas moves faster than both, carrying a hyperbolic excess velocity near 39 kilometers per second. This speed is not just motion, it is memory. Each kilometer per second reflects gravitational slingshots, stellar encounters, and long centuries drifting through galactic tides. When scientists reconstruct their past trajectories, the results produce a kind of astronomical poetry. Oumuamua may have passed near Vega, though not born there, and may have wandered the galaxy for hundreds of millions of years. Borisov's path leads back toward a region of young stars as though it were flung away from a chaotic young system. Atlas, with its high velocity and unusual composition, may have been shaped by a colder, dimmer star, or a massive companion object capable of imparting extraordinary energy. Their paths are not just mathematical lines, they are fingerprints. Yet despite all these clues, nothing truly explains why each object behaves so differently. Why did Oumuamua accelerate? Why is Borisov's chemistry so extreme? Why is 3I Atlas brightening beyond predictions and forming structures that defy conventional comet physics? The explanations remain incomplete, as if we are reading the universe in fragments, and in a way we are. Each interstellar visitor gives us only a glimpse, a brief encounter, before disappearing forever out of reach. Oumuamua is gone. Borisov is gone. Atlas will soon follow arcing back into the cold where sunlight no longer reaches. We are left with data points, spectral lines, images, and the lingering feeling that we're missing the larger picture. But perhaps that is the true gift of these objects. They remind us how little we know. They remind us that the universe is not obligated to simplify itself for our understanding. They remind us that some mysteries are meant to be observed, not solved. And so, traveller, let yourself rest in the not knowing. Let the diversity of these visitors calm you rather than unsettle you. Somewhere between the stars, countless others drift just like them, untouched, unseen, slowly crossing the darkness, until one day they too brush past our sun. Somewhere beyond our reach, something ancient still moves. Sleep, traveller, the cosmos will keep watch. The deeper astronomers look into Three-Eye Atlas, traveller, the more the object behaves like a riddle that refuses to hold still. And so the scientific community enters a familiar but unsettling state, that quiet war between hypotheses, where evidence is sparse, time is slipping away, and the universe refuses to reveal its full design. This is where science becomes a meditation, a slow breath, a willingness to sit with the unknown. Researchers approach this mystery the way one approaches a distant lantern in fog. Every measurement sharpens some edges while dissolving others. Every observation reveals a truth paired with a contradiction. And in this delicate dance, astronomers must decide which uncertainties to trust and which to release. The most fundamental debate begins with the nucleus itself, the heart of the anomaly. Observations place its size somewhere between 0.3 and 5.6 kilometres, a margin so wide it suggests not a lack of intelligence but a lack of access. Atlas's vast expanding coma masks the core blending light and shadow in ways that deceive instruments designed for simpler objects. Some models claim a high albedo surface, reflecting sunlight like powdered ice. Others insist on a darker, denser nucleus absorbing heat with unnatural efficiency. Neither interpretation stands firmly. Both feel like guesses whispered into a cosmic wind. And in this ambiguity, traveller, lies a tender truth: the universe does not owe us clarity. Sometimes the shadow refuses to separate from the light. The chemical composition deepens the confusion. James Webb's early spectroscopic data revealed a coma dominated by carbon dioxide, an alien chemical signature, compared to the water-rich comets of our own system. It was a clean, elegant detection. But then the green glow appeared, a hue typically produced by diatomic carbon, a molecule not strongly present in earlier observations. The paradox left researchers uneasy. Was the green emission a sign of photochemical reactions unfolding in real time? Or had the initial measurements simply missed hidden compounds, waiting for the right temperature to awaken? Earth-based observatories detected trace cyanides and organic molecules, suggesting that Atlas carries a complex chemical inventory far richer than expected. But the atmospheric distortion of Earth, combined with the comet's rapid brightening, introduces uncertainties that propagate through every model. Each dataset contradicts another. Each contradiction pulls scientists toward new interpretations they barely have time to explore. The anti-tail, that strange plume pointing toward the sun, creates the most heated discussions. Classic comet physics cannot easily explain it. Dust should be pushed away from the sun, not toward it. Yet Atlas seems determined to misbehave. Some theorists propose unusually large dust grains launch sunward at high velocities. Others invoke magnetic interactions between charged dust and the solar wind. Still others imagine unique rotation states with jets erupting in directions that counter gravitational intuition. The disagreements are not hostile, they are reverent. Each theory offers a way of respecting the anomaly. None claim certainty. The universe, after all, rarely offers it. Rotation state 2 remains elusive. Astronomers attempt to detect periodic changes in brightness, the subtle flicker that reveals spin. But Atlas remains stubbornly quiet. No clear rotation curve, no rhythm to its glow. Perhaps it rotates slowly, keeping one face heated like a world with locked tides. Perhaps its shape is nearly spherical, or perhaps its rotational signature is buried beneath its enormous coma, like a heartbeat muffled under blankets of dust and gas. Whatever the cause, the silence of its spin complicates every prediction. Brightness evolution introduces its own layer of uncertainty. Observers agree that Atlas is brighter than any model predicted. but by how much measurements differ between telescopes, between filters, between nights of varying atmospheric clarity. Some report brightness surges equivalent to multiple magnitudes. Others detect more modest deviations. The result is a constellation of competing light curves, each telling a slightly different story. This is not incompetence. This is astronomy at the threshold of instrument sensitivity. A faint cosmic visitor racing through space, changing faster than our tools can adapt. The uncertainty is not a failure. It is a fingerprint of the phenomenon. Origin theories create an entire galaxy of debate. Backtracking Atlas's path through the Milky Way suggests a birthplace somewhere in the thin disk, but the thin disk spans thousands of light years. The reconstructed trajectory diverges into dozens of possibilities. A young star, an old system with fading light, a binary pair. The error bars widen with every million years traced backward. All that remains certain is this: Atlas was not born anywhere near here. Its chemistry supports this idea. A CO2-rich nucleus implies a formation environment colder or chemically distinct from our own. Perhaps a star cooler than the Sun. Perhaps a system with different carbon to oxygen ratios. Perhaps a planet-forming disk shaped by conditions that do not exist here. And quietly below the surface of these discussions lies the humbling implication. Planetary systems across the galaxy are not variations of ours. They are not siblings, they are strangers. Structural stability provides its own puzzle. Is Atlas a solid monolith, or a loose aggregate, a rubble pile ready to fracture under the thermal stress of perihelion? Its expanding coma suggests vigorous outgassing, implying a wealth of volatiles near the surface. But its behaviour lacks the chaotic, flickering typical of unstable comets. It is lively yet controlled, active yet composed. Researchers cannot decide whether it is fragile or resilient, whether it will survive perihelion or silently tear itself apart. The 2AU switch-on moment haunts every discussion. Why did Atlas's activity surge so suddenly when it crossed that threshold? Was it the ignition of deeper ices awakening after a million years of cold? Was it the exposure of a new surface patch cracked by thermal stress? Or was it the moment when the physics of interstellar chemistry finally collided with solar radiation in a way no model had anticipated? Every theory leads to another question. Every question deepens the wonder. And so Traveller the scientific community does what humans have always done in the face of vast uncertainty. They think, they debate, they disagree gently, and they wait. They wait for data that may never come. They wait for the comet to re-emerge from solar glare. They wait for the universe to decide how much of itself it will reveal. Some mysteries aren't meant to be solved, only observed. Rest in that thought. The cosmos is thinking. When confronted with an object as strange as 3i Atlas, Traveller science begins with humility. Before reaching for the extraordinary, astronomers return to the familiar, to the quiet machinery of physics, chemistry, and sunlight. They ask whether the answer might already exist within the universe we know, even if hidden in its colder corners. A carbon dioxide-rich nucleus is the first clue. It suggests that Atlas may have formed far beyond the warmth of any star in a region where CO2 could freeze into solid ice while water remained vapour. Such places exist only in the distant shadows of planetary nurseries. If Atlas was born there, its unusual chemistry becomes less alien and more inevitable, a relic sculpted by temperatures our own system never experienced. Its violent brightening, its vast expanding coma, even its unpredictable jets, may simply reflect that chemistry awakening for the first time in millions of years. Solar radiation might be stirring ices untouched since the comet's birth, releasing gas and dust, with a force that defies our expectations only because we have never witnessed such a composition before. The strange sunward-pointing plume may also have natural roots. Dust grains launched at high velocities combined with electromagnetic interactions in the solar wind can create structures that momentarily appear to violate comet physics. These processes are rare, but not impossible. Atlas may simply sit at the far end of the physical spectrum, a reminder that nature contains extremes we seldom encounter. Even the eerie green glow has a mundane explanation: diatomic carbon awakening under ultraviolet light. fluorescing like a quiet emerald lantern in space. And so before we whisper of darker possibilities or stranger origins, science pauses here in the realm of the natural yet unfamiliar. It's all right to not understand everything at once. And now, traveller, our journey drifts toward its quiet ending. We have followed 3 Atlas as far as Earth's small vantage point allows, past its brightening, past its strange behaviour near Mars, and into the deep silence where the comet now hides behind the sun. Whatever it becomes in the weeks ahead, one truth already feels certain: the universe has reminded us gently and unmistakably that it is still capable of surprise. In watching this visitor, you and I have shared something rare, a moment of cosmic uncertainty suspended between what we know and what waits just beyond our reach. Whether Atlas reappears unchanged, shattered, or newly transformed, its passage has already expanded our understanding of what drifts between the stars. It has shown us that the galaxy is richer, stranger, and far more creative than we ever assumed. You are small, yes, but not insignificant. You looked up tonight. You listened. You wondered. That is the quiet bravery of being human in a vast and ancient universe. As the cosmic clock continues its slow turning, more revelations will come from Mars, from the spacecraft waiting in silence, from the first December images that break through the glare. And if this story found you tonight, listener, perhaps it will find you again when the sky opens. Until then, stay curious, rest well, traveller, the universe will keep watch. The